Alright, so finally the last examples that we have, we need to consider the equation of cosine of negative 1/2. So to solve this algebraically, we'd actually have to take the inverse of both sides. And how many solutions does the cosine inverse of negative 1/2 have? Well, then we scroll back up, and we're like, okay, cosine, its domain is only between -1 and 1. And I only see that one point hits anywhere near -1/2, so it would only have one solution. And if they wanted to be a jerk and we had to do this by hand, this would actually, we'd have to figure out that this is a 60-degree reference angle, and it would be in the second quadrant, making it 2 pi over 3, yeah. Alright, so the next one, it says, suppose we're asked to solve cosine of -1/2 on the interval from 0 to 2 pi, find all solutions. So this just basically tells me graph one period of cosine of x. Alright, so easy enough. Rough sketch. And so graphing one period of cosine, I see that it equals -1/2 somewhere down along here. And so it'd be this point and this point, which would actually be at x equals 2 pi over 3, or that next point right here would be at 4 pi over 3. Or we can probably use our unit circles that we need to be really familiar with this year, and see where your x coordinate of cosine would be -1/2, and it should be also at these values. But seriously, guys, I cannot emphasize this enough. Start memorizing your unit circle. It will make your life so much easier this year. Oh my gosh. So much easier. So just know it, get it back out, study it. I will start giving you guys pop quizzes. I'm not kidding about that anymore. I will start having pop quizzes. I will start with the first quadrant. Once you memorize the first quadrant, it should be all the way around pretty soon after that, because it's just reflect after you memorize the first quadrant. Alright, on C, what if we're asked to find and solve cosine of -1/2? What are all of the values of x? Alright, so this one's a little bit different. So we know at some point x is equal to 2 pi over 3, and we also know that x is equal to 4 pi over 3. And just like when I did with domains and things like that, I'm just going to say plus 2 pi k on both of them, because I just use k as a constant. You can use c, because we're going to be using c a lot this year as well. It doesn't matter to me, guys. Just pick something for your constant. I don't mind. Alright, so now we got to worry about where secant of x is equal to 3. So remembering our secant graph is based off our original cosine graph. It just gets asymptotes where cosine was 0, because we can't divide by 0. Other than that, it's the exact opposite directions as our original cosine graph. Again, it only touches at that maximum / minimum. That's the only dot that overlaps, the only point that overlaps. Alright, so if we were doing this graphically, we'd have to figure out, okay, well, where is secant 3? Well, that's going to be somewhere up, way up here on that asymptote, which is going to be a pain in the butt. And if I don't have a calculator, that's kind of a problem. The next thing is, well, also, we could do the inverse, but then our calculator doesn't have the inverse button, which is really unfortunate. So what do? We're kind of stuck. Well, all is not lost. So what we can do is we can remember that secant of x is just 1 over cosine of x. And we know that that's equal to 3. Well, doing some math, well, who would have thought? We're doing math in math class. I'd get 1 is equal to 3 times the cosine of x. Otherwise, cosine of x, dividing off that 3, should be just 1/3. So we can actually do this in our calculator. We can type in cosine inverse of 1/3 is equal to x. And when we type that in, we should get x is approximately 1.231 radians. Alright, but cosine of a third should be approximately like right here. But then we also have another one within our 2 pi, which should be over here. So how the heck do we get that other point? Well, that would go back to our unit circle, which way back in the day, we know that this is 3 pi, or not 3 pi, 3.14 because that's pi. And then this is 0 over here, which means that up here would just be pi halves, which is approximately 1.57, etc. So my reference angle of 1.231 blah 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 should be about here. And so then I gotta remember, okay, where else would my cosine be a positive 1/3? Well, cosine's my x value, so if I have to be on this side of my x-axis in order for it to be positive, that means that I need to stay on the same x-axis, but go down. That way my x value doesn't change. So, using my reference angle, this would also have to be 1.231 away from that x-axis. I can't just go down 1.231 radians, though, can I? No, because I have to stay within this particular value between 0 and 2 pi. So how I'm actually going to find that value that I just marked is I'm actually going to have to go all the way around, the long way around, and figure out what this distance is. So how I'm going to do that is I'm literally going to take 2 pi minus that 1.231, etc., etc., etc. that we got to actually find what that angle is. That way it's between 0 and 2 pi. Which I had to retype that in. So I should get 5.052 radians, all that kind of deal. Remember, radians is abbreviated rad. Other than that, have a great rest of your day. I'll see you tomorrow.